Okay, so recently I've been talking a lot in videos about the whole idea of cheaper models and faster models and being able to use them over some of the more expensive models a lot of the time. And the big reason for doing that is I'm just seeing so many people waste so much money with doing calls to GPT-4 for everything, or calls to Claude Opus and stuff like that for lots of things where they don't actually need that kind of model. They would be much better to go for a faster model and a cheaper model. The one challenge with that has always been, well, what if some of your calls to the LLM actually do need the big model or do need the more powerful model? So what I want to talk about in today's video is something that's been released by LMSys. So this is the people who run Chatbot Arena, who were some of the first people to create models like Vicuna. And for the past year plus, they've been benchmarking all the different models, giving them an ELO score, that kind of thing. So one of the cool things that they just released earlier this week was this new open source framework called RouteLLM. And this is basically an open source framework for cost-effective LLM routing. So the idea here is that sometimes you're going to be using your cheaper model, whether that's a Llama 3 8B, whether that's a Gemini Flash, whether it's a Claude Haiku, something like that. And then at other times, you're going to want to use your really powerful model like the GPT-4, the Claude Opus, like Gemini Ultra, that kind of thing. But the challenge is, how do you decide when to use one versus the other? So most of the time up until now, what I've generally done for projects that I've been working on is that certain calls I make to the cheaper models and certain calls I make to the more expensive models. What this framework actually proposes is that you've got this router in the middle that looks at the call, looks at the prompt that's coming in, and decides, hey, is this best suited to a really strong model like GPT-4, or can we just answer this with a weaker model like a Gemini Flash or a Llama 3, etc. And by doing this, they're able to then get this router to decide which model gets used based on the query that's coming in. Overall, this saves a lot of money. So if we look into their blog post a little bit, we can see that what they're saying here is that this is making cost savings of over 85% on various data sets that they've tried out there, that it's still able to get a very high level of accuracy on those benchmarks, but it's able to do it by deciding that actually this particular question, we don't need the top model, we can go for a cheaper model. And so therefore they're able to make cost reductions of so much on each data set. It also shows us that things like the GSM-8K data set is probably actually a lot harder, obviously, than certain other things. So the cost savings are actually lower on that because it's probably falling back to GPT-4 for a lot of those as compared to some other data sets out there. And you can see even with these cost savings, they're still able to achieve 95% of GPT-4's performance in here. So this is a really nice idea that they've put out as a paper. But far more than that, they've released the open source framework, they've released the code, they've released the data sets that they use to do this, and they've released the models that you can actually take and start putting this in production. So if you do have an app that's in production and you're looking at ways to save money on this, and I know that quite a few of the apps that are out there in production now are sort of often borderline between being profitable versus non-profitable and stuff like that. And a lot of it comes down to what models you're actually using. So this kind of thing allows you to have the benefit of when 80% of your queries really could be done by a cheap model and you only need the really strong model for 20% of the queries. It gives you massive cost savings in doing this. So let's look at how they actually do this. So what they did was they've got a bunch of data sets already of human preference data, of knowing that when for this particular question, someone typed in model A said this, model B said this, and people picked model A over model B 80% of the time or something like that. From that, they're able to build a number of different models to try and predict that on things that they haven't seen before. So the obvious sort of way to do this is you would take an embedding, right? And that's what they do. They actually, I think, use the OpenAI small embeddings in doing this. But then once they've got that data, they look at different ways that they can, use that and train that. So one of the first ways that they do this is a similarity weighted thing. So this is basically where they're working out a weighted ELO calculation based on similarity of the embeddings. And it's a little more complicated than just doing a cosine score. They have to work out the similarity and then also that related to the different models in there. The second one that they do is a matrix factorization model. So this is cool. So where they've got, imagine you've got a really big matrix of where you've got some data that you know that, okay, this model is better than this model for this particular phrase. But for a lot of it, you're missing data. So what they do is they come up with two matrices that they can then multiply to try and approximate the data that they've got. And at the same time, it fills in all the empty spots that they've got as well. So by using that, they're then able to predict that, okay, for this new kind of thing that we haven't seen before, this is the model that most likely is going to work. And it turns out that this one is probably the best model, which I'll talk about as we come back. The third one is where they're using a BERT model and training up a classifier for it. And the fourth one is kind of similar, but they're using an LLM classifier for it. If you look at the results in here, what we're looking for is this kind of efficient frontier of working out what model you should go for based on this efficient frontier in here. When they train this up on just the dataset pairs that they have themselves, they get out a model. But then what they also worked out that they could do was augment this data. So basically, they could use GPT-4 to be like a human and judging as well in there. And that turns out to work out quite nicely, that when you then train up your models on this augmented data as well, almost I think all of them improve. And this matrix factorization seems to do really well. This is where they're using the model to predict, and it ends up using GPT-4 26% of the time, and I guess the other model the rest of the time. And that turns out to be half as cheap as just going for a random baseline for doing this. Another thing that they found that was really interesting here was that while they did their training on Mixtral versus GPT-4 models, the actual models that they end up making that make this prediction of which LLM to use works really well even when you swap out the models. So when they changed the Mixtral for Llama 3 8B and the GPT-4 for Claude Opus, you can see that the model still works out which model to actually use in here. So again, you see these cost savings and stuff like that from this. Finally, just to finish up, there are some commercial services out there that have been offering things like this for people to be able to run their calls through this, and it would decide what to use. And they show that basically, what they're releasing as open source here actually is doing just as good as the commercial ones, and then obviously also a lot cheaper and stuff as well in here. So just to finish up, I would say if you're doing a project where you're going to put an LLM into production and you realize that sometimes you need a really strong model and a lot of the times you're perhaps not going to need a strong model, this is definitely worth considering and worth checking out here, this RouteLLM from LMSys. Not only have they released the code so you can run the models that they've got and use the routers that they've made there, they've also got everything that you need to basically make your own routers. And we can see that they've released all the models as well as the data sets on Hugging Face here. So this allows you to basically look at these yourself and try them out yourself. I imagine the open source community will be able to build on this and come up with things of where you're comparing all the different popular models that are out there. So in some ways, perhaps this is not a super sexy topic, but if you do anything where you're spending quite a bit of money on tokens, this is definitely something that you should be checking out for using in production and stuff. All right. As always, please put any comments and questions in the comments below. If you found the video useful, please click like and subscribe, and I will talk to you in the next video. Bye for now.